Hello friends, welcome back. So this is the second installment in the series solution of triangles. Here we'll be trying a few problems and seeing how the various formulae we learnt in the previous video will be useful in solving questions. So the first question is a very straightforward one. It says find the ratio of sides of a triangle whose interior angles are 30 degrees, 60 degrees and 90 degrees. Now all the angles are known and we're just supposed to find the ratio of sides. So the easiest formula obviously is the sine rule. Okay. So let the sides be ABC and the triangles capital A, capital B, capital C. So using sine rule we have A by sine A equal to B by sine B equal to C by sine C. Let the angles ABC be respectively 30, 60 and 90 degrees. Hence, A is to B is to C is equal to sine A is to sine B is to sine C is equal to sine 30 degrees, sine 60 degrees and sine 90 degrees. Now sine 30 is 1 by 2, this is root 3 by 2, this is 1. Hence the ratio can be written as, there are a lot of ways to write the ratio. It's preferably written in this format. Instead of writing them as fractions as 1 by 2 and root 3 by 2, it's better to write them as 1 is to root 3. So we just use the sine rule and we got the answer. Let's move to the next question. Okay, so in this question, because tan squared A is, because this the proof has a term tan squared A, which can be written as cos squared A minus sin squared A. So we will try to use the cosine rule somehow. Okay, now first applying the cosine rule on the sides given here, B and A, B and the angle A. So let's write the cosine rule for A. That gives us B squared plus C squared minus A squared by 2BC. Rearranging the terms, we get C squared plus B squared minus A squared minus 2BC cos A equal to 0. So this can be written as minus C into 2B cos A plus B square minus A square equal to 0. Now he says C1 and C2 are possible values of the third side. The third side is C and we have obtained this quadratic relation here. So that means C1 and C2 must be the roots of this equation. Now as we know that the roots of the equation satisfy certain conditions, which are C1 plus C2 is equal to the negative of this term, hence we get 2b cos A, and C1 C2 is equal to the coefficient, so we get b squared minus A squared. Fine. So now that we have obtained this, let's try and substitute them in the left hand side of the required condition. Hence LHS is C1 minus C2 whole squared plus C1 plus C2 whole squared into tan squared A. But C1 minus C2 whole squared is C1 squared plus C2 squared minus 2C1 C2, which can be further written as C1 plus C2 whole squared minus 4C1 C2. Right? Because there is a plus 2C1 C2 here. Minus 4C1 C2 gives minus 2C1 C2, which further gives C1 minus C2 whole squared. This is the exactly same thing. Now we know all the C1 C2 those terms here. So let's substitute. So what is C1 plus C2? C1 plus C2 is 2b cos A, squaring gives it 4b squared cos squared A. C1 C2 is b squared minus A squared plus C1 C2 again gives us 4b square cos square a. Now I write tan square a as sin square a by cos square a. That cancels it. Now let's expand this. Expand all the terms here. Minus 4b square plus 4a square plus 4b square sin square a. Now the 4b square sin square a and 4b square cos square a give us 4b square, right? Cos square a plus sin square is equal to 1. Minus this, hence these terms cancel each other and we get b square, which is equal to RHS. Hence proven. Hence we use cosine rule here to find out what the possible values of C1 and C2 could be, and using that we solve the or we prove the given condition. Okay. So let's go to the next question. Okay, if delta is the area of triangle here. So if area of triangle is given as a squared minus b minus c whole squared, we are supposed to find the cotangent of angle A. Fine. So let's see how to do this question. Okay. Now let's expand the whole thing here. It gives us a squared minus b squared minus c squared plus 2bc but this term here, this part, now that can be written as minus 2bc cos a, right? Because cos a would be b square plus c square minus a square by 2bc. Hence this part is minus 2bc cos a. So this is 2bc into 1 minus cos a. Now what is delta? Delta can always be written as half bc sin a. And the right hand side is 2bc into 1 minus cos a, which can be further written as, okay, let's write it in the next equation itself. Sin a is 2bc. 1 minus cos a itself is equal to 2 sin squared a by 2. Okay, sin a can be written now further in terms of 2 sin a by 2 cos a by 2. Anyway, first let's cancel bc here. This is half into 2 sin a by 2 cos a by 2. That is equal to 4 sin squared a by 2. This cancels, sin a by 2 sin a by 2, 1 power cancels. So we get tan a by 2 is equal to 1 by 4. Actually, I cancel sin a by 2 here, which usually you shouldn't do. But here we are sure that the angle can't be 0. And sin a by 2 is 0 only when a is equal to 0. Or a is equal to 180 degrees. Now, both of these conditions aren't possible in a triangle. So I go for, I go ahead and cancel the sin a by 2 term, and so I get the, cos a by 2 on the left side and 4 sin a by 2 in the right side. That gives me tan a by 2 is equal to 1 by 4. Now if tan a by 2 is equal to 1 by 4, tan a can be written as 2 tan a by 2. From multiple angle formula we know this, minus tan squared of a by 2. So that is equal to 2 into 1 by 4 minus 1 by 4 squared. That is half by 1 minus 1 by 16. The denominator is 15 by 16. So solving this we get tan a is equal to 8 by 15. Hence cot a is equal to 15 by 8. Okay. So this is how we find the answer, find the given the required trigonometric ratio here. So cotangent A is equal to 15 by 8. Okay, so this is the fourth question now. So the question says, if the sides of a triangle are in geometric progression with common ratio k and k is less than 1, so find the minimum value of k. Lower bound means the same thing, minimum value. Okay. So since the sides are in geometric progression, so I'll write the sides as this: A is say A, B is AK, and C is AK square, right? Now I have the triangle inequality, which says the sum of the sides is greater than sum of two sides is greater than the third side. Now I have that k is less than 1. That means A is greater than B and B is further greater than C, right? Moreover, so A is the larger side, so I'll use the triangle inequality on the third side, which means B plus C will be greater than A, right? Now what is B plus C? B plus C is AK plus AK squared, which is greater than A. Since A is common, I just cancel it. Moreover, we are sure A is a non-zero number. So it is K square plus K is greater than 1. Now I try to solve this equation using squaring this, completing the squares method. That is K square plus 2k into 1 by 2, right? And this is 1 by 2 squared, this is 1 plus 1 by 2 squared. That gives me k plus half squared is greater than 5 by 4. Right? Okay. So let's take the square root. So that gives me k plus half is greater than root 5 by 2. So that means k must be greater than root 5 by 2 minus half, or written simply half of root 5 minus 1. So this is the lower bound. So we know that k is less than 1, but we also now know that k is greater than half of square root 5 minus 1. So let's move to the next question now. This question says the x radii R1, R2 and R3 are in HP. HP stands for harmonic progression here. Prove that ABC are in AP. Now if the area of triangle is 24 cm square and perimeter is 24 cm, find the length of the sides. Okay. Now for this question, we'll use some of the standard formulae of R1, R2 and R3. So R1 is written as delta by S minus A, right? So similarly R2 is delta of S minus B, R3 is delta of S minus C. So we know about harmonic progression. So when three numbers are in harmonic progression, their reciprocals are in arithmetic progression. That means 2 into 1 by R2 will be equal to 1 by R1 plus 1 by R3, right? Because R2 is the middle term, twice of inverse of that must be equal to sum of the inverses of the other two terms. Now let's substitute our formula here. 2 delta, it should be, so it's 1 by R2, that means this must be S minus B, and here delta is denominator. Similarly S minus A by delta, S minus C by delta. Delta is the common denominator everywhere, gets cancelled, and we get 2S minus 2B, S minus A plus S minus C. Hence we get that 2B is equal to A plus C. But isn't this the formula for arithmetic progression, right? So that means ABC are in AP. Hence, the first part of the problem is done. We know that we now know that ABC are in AP. So this is for in general. If we know that the x radii of a triangle are in harmonic progression, we know that the sides of the triangle are in arithmetic progression. Now let's see how to solve the next part of the question. So the next part says the area of the triangle is 24 centimeters square. So we know what delta is, right? Now we also know what the perimeter is. So delta, that is equal to 24 centimeters square, and perimeter, that is a plus b plus c, is equal to 24. Now if a plus b plus c is 24, what is s? S is 12 centimeter, right? Okay. So from this we have now delta can be written in using Theorem's formula: s minus a, s minus b, s minus c, right? So 24 is equal to 12 into 12 minus a, 12 minus b, 12 minus c. But what do we know about a, b and c? We know that a plus b plus c is equal to 24, and that a plus c is equal to 2b, or b is nothing but a plus c by 2. So a plus c into this is equal to 24, right? So b must be 8 centimeters. Okay, so 24, let's square it. 24 square is equal to 12 into 12 minus a. Now b is 8, so 12 minus b will be equal to 4, and the third term is 12 minus c. But from this equation we have a plus b equal to 16, so c must be 16 minus a. So this is 12 minus 16 minus a. Now this 24 into 24, this 12, 12 minus a into 4 into 12 minus 16 is minus 4, that is a, that is a minus 4. 1 12 and this equals 2, this cancels, and we have another 12 here. So 12 is equal to minus a square, 12a plus 4a minus 48. So let's rearrange: a square minus 16a plus 60 equal to 0. Okay, so now factorizing this, we get a minus 6 into a minus 10 equal to 0. The sum is 16 and the product is 60, so 6 and 10, right? So a can be 6 or a can be 10. Both of these are completely valid solutions now, till now. So now let's see what the values of c can be. If a is 6, then c will be 10. If a is 10, c will be 6. Hence, we actually have two sets of sides here, because both of them are completely the same thing and completely valid. Hence, sides in general are written as 6, 8 and 10. Okay. So here we used the formula of the x radii, and using that and the Heron's formula we find out the sides of the triangle. Let's move to the next question. This again is on x radii, and it says that the product of sum of two x radii taken at a time is equal to 4 into r into s square, where r is the circumradius and s is the semiperimeter. Okay. So again we look at this question Now we'll again use the same formula of R1. So let's see what R1 plus R2 is. We know R1 is equal to delta by S minus A. So this is, now why I take only the first term is because the other two are symmetric, and hence if I get some kind of symmetric solution, symmetric expansion here, I can just write for all the other terms. So this is delta into S minus A, delta into S minus B. This is 2S minus A minus B by S minus A, S minus B. Now we know that 2S is nothing but A plus B plus C. So 2S minus A minus B must be equal to nothing but C. So this is equal to delta C by S minus A, S minus B. Right. Similarly, the other ones can be written as, now we see that it just depends on C in the numerator. So R2 plus R3 will be delta A by S minus B, S minus C. R3 plus R1 is delta B by S minus A, S minus C. Hence the LHS is delta cube ABC by S minus A square, S minus B square, S minus C square. We get S minus A twice, S minus B twice, S minus C twice, so it just becomes square of all the three. Now let's expand delta in terms of the Heron's formula. So we get, this is, instead of that, let's write ABC as 4R delta. So we get delta cube into ABC is 4R delta S minus C square. Now we have delta for 4. Now why I didn't write in now why I didn't expand delta in Heron's formula in the previous step was because there would have been a half integral 3 by 2 would have come there, because Heron's formula converts into square root of product, and this was just 3, an odd number. But now I have an even number, so I'll expand now using, because now I can easily remove the square root sign. So this is S into S minus A, S minus B, S minus C whole power 4 by 2, that is square of all this. So square into 4R by S minus A square, S minus B square, S minus C square. So these terms get cancelled. What I am left with is 4R square, which is my RHS. And say, hence this is proven. So this again is a general condition which is easily, or a general theorem which is easily proven using the simple formula and then the Heron's formula. Okay. So moving to the next question. If in triangle ABC, 2 cos A by A plus cos B by B plus 2 cos C by C equal to A by BC plus B by AC, find angle A. Okay. So in this question, since there are all cos A and only sides are given, I think what I will, from my intuition, I think cosine rule should be helpful. So let's go ahead with it. Okay. So this expanding completely gives me B square plus C square minus A square by 2BC. But there is already an A, it becomes 2BCA. Similarly, by 2AC into B plus 2 by 2ab into c equal to a by bc plus b by ac. Right? So now the denominator is same for the left hand side, so I'll just see how I can contract the numerator. That is, for a square I have minus 2a square plus a square plus 2a square. This is only a square. For b I have 2b square minus b square plus 2b square, so that is 3b squared. For c squared I have 2c squared, c squared and minus 2c squared. So again I have again have c squared by 2abc is equal to a by bc plus b by ac. Fine. So this is not helpful. So I'll try some other kind of Okay. So I'll now try expanding the right hand part. Well, that gives me, this part gives me a squared plus b squared by abc. Fine. So I can now cancel the denominators, and what I have is a square plus 3b squared plus c squared equal to 2 times a squared plus b squared. Okay. So I have, this is a squared plus 3b squared plus c squared, 2a squared plus 2b squared. So 1 a square and this cancels, 2b squared and this cancels. What I have is, I just have a square is equal to b square plus c square. Now note that I don't have anything in terms of angles, but I know that a square is equal to b square plus c square is nothing but the Pythagoras Theorem. That means this angle, the angle opposite to this side must be 90 degrees, and that's what is asked in the question, fortunately for us. So a is nothing but 90 degrees. You can actually further use cosine rule and say write cos a, so you will get that equal to 0, which again proves that a is equal to 90 degrees. Okay. So let's move to the next question. The next question says, if XYZ are lengths of perpendiculars on sides BC, CA and AB of triangle ABC, prove that A by X plus B by Y plus Z by C is equal to, it must be the other way. This must be C by Z, that has to be symmetric. Okay. So this is C by Z is equal to A plus ABC by 4XYZ. Okay. Okay. So in this question, it's better to draw the diagram first. Usually that helps us a lot. So let this be my diagram: A, B, and C. So let the circumcenter be somewhere here, and circumcenter is equidistant from the 3 edges. But this is what is given to us, right? This is X, and similarly to this one it will be Y, and to the next one it will be Z, right? Now this whole angle is A, but I know that the triangle, so this is O in triangle OVC, OB is equal to actually OC, and hence I get that, say if I call this D, I get that BD must be equal to DC, right? This is actually, these triangles again will become congruent to each other, and I get that BD is equal to DC. Since the whole thing here is equal to A, I get that these two must be equal to A by 2. So what I get here now, since this is perpendicular, I can cleverly write X in terms of A. But what is this angle? Okay, so let's write this angle. So let this angle be alpha now. So that means cot alpha. Cot alpha is nothing but adjacent by opposite. So that is A by 2 by X. It is A by 2x. In other terms, I can now write A by X in terms of alpha. I have 2 cot alpha, right? Now, similarly, if I call this angle beta, if this is alpha, this must be alpha again. If this is beta, this is also beta, and if this is gamma, this too is gamma. Okay. So if A by X is 2 cot alpha, B by Y, okay, we can take this triangle, this one, and here you can get that B by will be nothing but 2 cot beta. Similarly, C by Z will be 2 cot gamma. Right? Now let's add all these together. So the LHS is A by X plus B by Y plus C by Z. It gives me 2 cot alpha plus 2 cot beta plus 2 cot gamma. 2 times cot alpha plus cot beta plus cot gamma. Now, if I look at these angles again, I see that the sum of the angles must be 180 degrees, and the sum of the angles is nothing but, if I start with A, it's beta plus gamma plus alpha plus beta. So the sum of the angles is nothing but 2 times alpha plus beta plus gamma, right? So sum of angles is equal to 2 times alpha plus beta plus gamma, which is equal to 180 degrees, right? So alpha plus beta plus gamma is equal to 90 degrees. Now, for this kind of system where sum of 3 angles is equal to 90 degrees, we know that cot alpha plus cot beta plus cot gamma must be equal to cot of alpha into cot of beta into cot of gamma, right? This is actually better remembered this way. Cot of A by 2 into cot of B by 2 into cot of C by 2, where ABC are angles of a triangle, is given is equal to cot A into cot B into cot C. That is just a particular one. In a general case, we can just write it this way. It is 2 cot A, 2 cot beta, gamma. Right? But what do I know about cot alpha, beta and gamma? From the previous formula only, from this one. Similarly, from the remaining ones, I can again write cot alpha in terms of A by X. So I get A by 2x, B by 2y, C by 2z. So this is now further simplified as 4 by xyz, which is equal to our right hand side. So here, just drawing the figure helped us a lot, and we can cleverly use whatever is given in the question to find out, and hence prove the given required condition. Thank you for watching this video. This concludes solution of triangles. In the next one, we will use trigonometry further to find out some more interesting things. Thank you.